Hi guys, welcome to another session of Beginner Python. So in this session, we will be talking about classes. So that's the natural extension of functions. So in the previous video, we saw that functions are used to sort of store some pieces of code, and you don't have to rewrite the code again and again. Rather, you can just call the function and the code will get executed. Right? Makes life a lot easier, especially when you want to include things like loops and you want to customize certain pieces of code for different users or things like that. Now, the class is a natural extension of that. And if you want the simplest definition for a class, you can say a class is a group of functions or group of similar functions, right? So let us say you want to write some code that for, let's say, a bunch of math functions, right? Mathematical operations. So let me first show you how it's done and then I can explain stuff. So I'm going to say class math operations, right? And I'm going to put a colon. So this is how you define a class, right? Now, next, what do we do? In every class, or at least in most classes, it's not a compulsory thing, but in most classes in the development world or ML world, we have something called a constructor. And a constructor is defined by underscore underscore init underscore underscore. And you have something called as self. Okay? Now, after that, as usual, you'll accept some parameters, comma A, comma B. So let's say that the whole idea is to apply math operations on two different values. So you would accept two values. Now, what is this self? We'll just come to that in a second. So next, what I'm going to do is I'm going to say self dot num1 is equal to A, self dot num2 is equal to B. Now, num1 and num2 are called as instance variables. They're called as instance variables. So what is an instance variable? An instance variable is a variable whose value changes for different objects. So value changes for different objects. So what does that mean? What's an object? Well, we'll just come to all of that in a second. But for now, remember that the self keyword is used to specify that a particular variable, in this case num1 and num2, are instance variables. Now what I can do is I can use this instance variable, these two instance variables, inside other functions. So what I can say is I can say add, right? I can say self. That means adding self allows this function to access these instance variables. So I'm going to easily access these instance variables. I'm going to say return self.num1 plus self.num2. Similarly, I can add one more saying define subtract. And I'll again say self. And once again, I'll say self.num1 minus self.num2. And you can guess the trend. I'm going to say define multiply. I can take self and I can say return self dot num1 times self dot num2. So it's this self that allows me to access these two variables, num1 and num2, anywhere inside this class. Any function inside this class, I can access them thanks to this constructor. So that is the role of a constructor in a class, right? So now life is a lot easier. I can run this and I can say, now let's talk about what an object is. So when I say object, it's nothing but, let's say I can say object1, and I can just say math operations, and I can pass two numbers. So even though I'm calling the class here and the variables are defined inside the constructor, I can still pass these two variables A and B inside the class parenthesis itself. That's what the constructor allows me to do. So I can now pass 5, 3. Now this is what I call an object. So for object 1, num1 and num2 refer to 5 and 3 respectively. Next, what I can do is I can say object1 dot add. I can say object1 dot subtract. I can do all these things. Now I can also say object1 dot num1. This will help me access this particular variable, num1. And I can put some other value to num1, let's say 10. Now if I want to do object1 dot add, what do you think will be the output? It's going to be 13, because now num1 is 10. I updated the value of num1 and num2 is still 3. Similarly, I can now update the value of num2 as well. And I can say num2 is 5. So now object1 dot add, or let me do object1 dot multiply, it should give me 50. Right? So this is what this beautiful thing called a constructor allows me to do. I can change the value of variables. I can update the values and I can do different operations. I can access these variables in anywhere inside the class. Super useful, right? Now, so we saw this as an object. So similarly, I can have different objects. I can say object 2, and now I can give different values to these objects like 15, 25. So that's object 2 from this using the same class, right? So that's what I meant when I said object, right? So this self gives the capability for different objects to have different values for these two variables. So these two variables, so it can be referred to by object num1, object1 dot num1 and object2 dot num1. And object1 dot num1 is different from object2 dot num1 thanks to this set of code, right? So I can create as many objects that I want, and each object will carry its own unique num1 and num2 within it, and it can be updated as and when you would like. That's the beauty of classes in Python, right? So that's about that's mostly how you would define a class on Python. So there's one more thing I can do, right? And let's say I want to add a variable right here. Like let me call it C. Let me say c is equal to some value 5. Now, what do you think will happen? Will this work? Will this not work? What do you guys think? Let me try. It'll work fine. And similarly, I can define an object, and just how I can access num1 and num2, I can also access c. Totally fine, not an issue. Now let me try something. Let me try something like this. Let me add this c into all these functions. Will it work? Right? Let's see if it works. Now look at that. It doesn't work in the same way anymore because it says c is not defined. So even though the c can be defined inside a class, this is called a class variable and it is not an instance variable. That means I cannot access this variable c directly inside all these, right? So only instance variables can be accessed. However, if I want to do things like update the value of c to 10, something like that, I can still do that, right? So I can still do something like this, and now my object1.c is going to be updated to 10. So that is still possible. Just the only thing is that you cannot access these inside any other function, or you cannot access it even right here, right? So that's a difference between a class variable and an instance variable, something that's commonly asked in interviews as well. So that's the main difference, right? So again, what kind of functions are included in the class? Similar functions. For math operations, you have math functions. If you have any if you have any kind of function, like let us say a function for handling sports, or a class for handling cricket, you can probably have functions that that define the scores of players, one function for that, one function that defines the strike rates, one function that probably defines the bowling stats. So similar functions. That's the whole idea of a class. Class can include similar functions, right? So what else is an important aspect, right? Now, can I include the properties of one class into another class? So when I say properties, what do I mean? Well, all these are the properties of my class math operations. So this constructor is a property of my class. These functions are the properties of my class. These instance variables are the properties of my class. All these are called properties of my class. So is there any way in which I can define two classes and one class can inherit the property of another class? So what do I mean by this? Let's take a look. So let me take another class and say call this advanced operations. Let me first define this and then let me explain. So I'm going to say advanced operations. Now inside the parenthesis, I'm going to say math operations. Okay, then what I'm going to do is I'm going to say define, divide, I'll say self, and I'll say return self dot num1 divided by self dot num2. And let me take one more. Say define power, and I'll say self, and I'll say return self dot num1, the power of self dot num2. Now this is a class called advanced operations, and I'm using divide and I'm using the power, right? As you can see, right? Well, now let's see if let's see if this will work. What do you think? Should this work according to what we have learned so far? So let me say object 1 is equal to advanced operations. Now let me take two numbers, 1 and 9. Look at that, it's working fine. Let me say object 1 dot divide. And look at that, it works absolutely fine. Now you might ask me, well, how come it's working? Because we don't have a constructor defined. We are not initializing our instance variables. How on earth is it working still? Well, that's the concept of inheritance. That's the concept of inheritance on Python. I don't need to define, right? I don't need to define the constructor separately. When I'm putting this math operations inside the parenthesis of advanced operations, I am inheriting the properties of math operations into this advanced operations, right? Now the math operations is called as the superclass. So this is the superclass or the parent class. And you can call advanced operations as the child class. And that's what this allows you to do. Super interesting, right? I don't need to. So I can define multiple classes and I can inherit the properties of one class into all multiple classes. Amazing concept. So what if, let us say, I want to include, well, here I don't have a constructor and I have to depend on my instance variables from the parent class math operations, right? Well, what if I want my child class, which is advanced operations, to have its own set of variables as well, own set of instance variables, along with the ones that are here? How do I do that? Is there a way I can do that? And the answer is 100% you can. So I can just take this, right? Now what I'm going to do is I'm going to say define init. I'm going to say self comma a comma b, or yeah, a comma b. And I'm going to say, I'm going to take another one called c. What I'm going to do is, I'm just going to say super dot init a comma b. So a comma b is going to get its values from the superclass or the parent class, right? And well, c is completely dependent on the advanced operations. So I'll take c here and I'll say self dot num3 is equal to c. So now I can do whatever I want. I can include self.num3 here as well. That's totally fine. It'll work. Then I can probably have another one here. Right? Looks like there, yeah. Right, so looks like I won't be able to do something like this here. It's commented by mistake. Right, now I can do something like object 3 is equal to advanced math. or advanced operations. And I can take 5, 6, 2. And I can do object 3 dot divide. And that should work fine, right? So it's taking the third number as well, and it's doing its thing. Now that is the whole concept of inheritance, right? So this concept is called inheritance. Super useful concept when it comes to classes. So, when people write new classes, new libraries, and they want to include the properties of a parent library. So, like in the future, you're going to learn about NumPy pandas, and pandas has pandas as parent library is NumPy. So this is how it's done, right? You define a parent class and you inherit the properties of the parent class into the child class. So that's about this video. This covers mostly what you need to know about classes. I'll see you in the next video. Thank you.